Alright, I just want to let you guys know that this is an optional video, and you should have the PowerPoint that goes along with it, so feel free to fast forward to any problems in particular you want to take a look at. You're not being graded on this. And I've just gone through a few problems that people tended to struggle with more. The first problem out of Chapter 12 gives you the fact that there's an angle in standard position and that the terminal side passes through a specific set of points, and you need all 6 trig ratios. So that means we need sine of theta, cosine, tangent, cosecant, secant, and cotangent. Now we are given an x and a y, and because this is not a unit circle, we need to calculate r. And so r is really just the distance formula. This happens to be a prime number, or it's not a prime number, but there is no way that we can factor out a perfect square, so we have to leave this as square root of 194. Here I did not require you to use any identities, so you can simply use x, y, and r to answer this. Sine we know is y over r, so that's 13 over the square root of 194. We do have to rationalize. Cosine would be x over r, but then when we rationalize that, it becomes tangent is easy, y over x. Cosecant is r over y. Secant is r over x. That's a 9, sorry. And then cotangent is x over y. These are all positive because this point is in quadrant 1. For this particular word problem, we're covering a couple of topics. First of all, right triangles, meaning SOHCAHTOA. Secondly, word problems. And finally, angle of elevation problems. With this word problem, we know that there's a tower, and towers are perpendicular to the ground unless it's stated otherwise. And the angle of elevation from this point on the ground to the top of the tower is given to us at 38 degrees and 20 minutes. And we're also told that this distance here, because it's 93.2 feet from the base, and we're asked to find the height of the tower. So with this angle, I have opposite, I have adjacent, which means I'm using the tangent. Not of 93 though. Rookie mistake. The tangent of 38 degrees, 20 minutes is equal to opposite over adjacent. And to solve this, I just put into my calculator 93.2 times the tangent. The thing you need to be aware of is that this is in degrees and minutes, so make sure your calculator is in degrees. When you do that, you find that the height is 73.693 feet. And as a word problem, you would write this out as a sentence. Okay, here you're given a triangle to solve. So what you need to do first is sketch the triangle. I have no idea what this looks like. I tend to make all my triangles look like equilateral triangles. Side A is opposite of angle A, and side B is opposite of angle B. And what I notice is that I have an angle and two sides. Now, it's side angle side if the two sides you have actually create the angle, but because they don't, this is actually a side-side angle problem, which means we're not allowed, so it's ambiguous case. If I could spell. That means we need to test to see if there are two triangles or only one triangle, or if there are going to be 0 triangles. We start with the law of sines. Into my calculator, I put 86.4, sine of 61.7 divided by 78.9, and then I take the inverse sine of that value, and that gives me angle B, which is 74.617 degrees. Now I have to test to see if a second triangle exists. That means I need to take the supplement of that angle. So 180 minus 74.617 gives us 105.383. This is not the thing that tells us if a second triangle exists. Our next step is to find angle C. So I will take 180, because that's the sum of all the angles, minus 61.7 as our set angle A, minus 74.617. And I get C sub 1 to be 43.683 degrees. To find C sub 2, I go through the exact same process. 180 minus 61.7 minus 105.383. And from there, I find that I get 12.917 degrees. This means that two triangles do exist. If I had happened to get a negative number here, then only one triangle would exist. If when I did my calculation way up here, I found that the sine of B was a value greater than 1, then no triangles would exist. In this case, I need to find side C for both triangles. So I will again do the law of sines. Here I'm using angle C sub 1 to find side C sub 1. And for side C sub 1, I get 61.89. And then for C sub 2, I'm going to use angle C sub 2. There is a 7 there, you just can't quite see it. Putting that into my calculator. This next problem happens to be a law of cosines problem. Obviously, you won't know that until you draw your sketch. So we've got two boats leaving a dock. They each travel in a straight line, and they create an angle of 54 degrees, 10 minutes between them. What we're told is their speeds. So we have a speed of 36.2, and we have a speed of 45.6, and we're given their time of 3 hours. So we multiply speed times time, and that gives us distance. This one is 108.6 and 136.8. So these are the sides of your triangle. And we're looking for this distance we'll call C. Now from here we have side, angle, side. We can use law of cosines to find side C. We take C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of angle C. Make sure that you are in degrees, and you will find that C squared is equal to 13,113.359. That is not your answer. Remember, you have to take the square root, and you get 114.514 kilometers. Many of us are still having problems with graphing. So to start this, I'm going to call your attention to the fact that this is existing here. We need to factor pi out of these parentheses in order to calculate the period of this graph. So what we will do is we will start by rewriting the equation. Now we can accurately get all the information we need for this. We know that the amplitude is a half, and the period of this is 2 pi over pi, which is 2. The vertical shift is 1, and the phase shift is to the right, 1. So amplitude is here. Period is 2 pi over this number. Vertical shift is here. Phase shift is here. Minus 1 here means going to the right 1. Now you're going to write what I call that 5-number summary. So you're going to start at 0 and you're going to end at 2, because that's the beginning and end of one period. You will cut this in half to get 1. From 0 to 1, halfway through is 1/2. From 1 to 2, halfway between there is 3/2. This is a cosine, so we know the pattern of cosine starts at 1. Next, we multiply the amplitude. After that, we add this vertical shift. And what we've got now is our graph before the phase shift. So these are your x values, these are your y values. So there's 1, 2, 3, 4, and you can move backwards. And we'll call this 1 and 2. And then at 1 we're at 3/2. Back to 0, back to 1, and then you can repeat this pattern. And you can also repeat it backwards. So from here, this is the bottom, we'll move back up. And you can graph that. Now, like I said, we're not done. We need to apply the phase shift, and the phase shift was every point gets moved to the right 1 full unit. So I'll start with this one and move it over to the right. And when I connect these points, the final graph is in red. I can also continue the pattern to the left because I do know what it's supposed to look like. The red graph is what is my final graph. When it comes to the graphs of tangent, cotangent, secant, and cosecant, really you have to be able to identify them. So with tangent and cotangent, which are the two on the top, what you need to look at is what is happening here at the y-axis. Tangent crosses the y-axis. Cotangent has an asymptote at the y-axis. That's how you tell those apart, regardless of whether they're positive or negative. For what we're assessing, I am not going to give you any with phase shifts. For secant and cosecant, the best thing to do is to connect the maximums and minimums with a wave function. And then looking at the wave that you've got, determine, is this wave a sine or cosine wave? Well, this one has its maximum on the y-axis, so this one's cosine. And this has its center at the y-axis, so that one has to be sine. Which means that the reciprocal of cosine is secant. The reciprocal of sine is cosecant. Next is everyone's favorite, proving an identity. This one is relatively simple because the right-hand side is 0. You will not be doing anything with this side. You will only be manipulating the left. The first thing that I recommend that you do here is represent these two cosecants in terms of sine. Then what I would do is I would multiply the numerator and denominator by sine. And the reason is because multiplying by sine over sine means you're really multiplying by 1. When you distribute, this will become sine, this will become 1, so it actually gets rid of these two fractions. Now you may look at this and say common denominators, but remember, subtraction is not commutative, so sine of theta minus 1 is not the same as 1 minus sine of theta. However, once again, I can multiply numerator and denominator by the same value so that I have a common denominator, and in this case that value is negative 1. Remember that you do have to distribute, so you get negative sine of theta minus 1 over negative sine of theta plus 1. I will continue up in the column over. This denominator can now be rearranged. When I do that, the numerator can stay the same, but my denominator is now 1 minus the sine of theta. Common denominators means that I can combine my two numerators. This should be a minus, by the way. Now when I combine like terms, positive sign and negative sign are 0. Positive 1 and negative 1 are 0. So I have 0 over 1 minus the sine of theta, which is equal to 0. And 0 equals 0. A couple of inverse trig problems. The first one, you would use a unit circle, and the reason you'd use your unit circle is because you've got this happening where it's giving you square root of 3 over 3. Remember that tangent exists only in quadrants 1 and 4. Let me rephrase that. Arctangent only exists in quadrants 1 and 4. And so I'm going to look for a value somewhere in these two quadrants where y over x, as in my y coordinate divided by my x coordinate, is equal to the square root of 3 over 3. As I look through these values, I note it could be pi over 3, could be pi over 6, could be negative pi over 6, or negative pi over 3. And I say negative rather than saying 11 pi over 6 because we have to move in the backwards direction. What I know is that this value is positive, so it's not going to be anything down in quadrant 4. It will be either pi over 6 or pi over 3. And so I calculate square root of 3 over 2 over 1/2 copy dot flop. Well, that's square root of 3. Do the same thing again. 1/2 over square root of 3 over 2 copy dot flop. That makes it 1/2 times 2 over the square root of 3. This becomes 1 over the square root of 3, and when I rationalize, it becomes square root of 3 over 3. So in this case, y is equal to pi over 6. So how do we know that we need the radian measure rather than the degree measure? The answer to that is whatever's happening here. If this is a y or an s or some variable, you're going to use radians. When it is a theta, you'll use degrees. So now let's take a look at the next one. Because we're given a decimal rather than something in radical form, what we need to do is put this into our calculators. Obviously, the calculator does not have a cosecant function. So the way that you will input this is that you will take the inverse sine of 1 over this number. And when you hit enter, you will find that theta is equal to 7.674 degrees. Finally, I thought we would look at an absolute value inequality. Remember that when you are working through these, you have to separate out to two separate inequalities. This is a greater. Greater, you hear the that means it's an or inequality. So you'll write 2x minus 6 greater than or equal to 8. Or, and this is where a lot of you made your mistake last time, 2x minus 6 is less than or equal to negative 8. It can't be greater than positive 8 or less than positive 8, right? So it'll be less than the negative value. Now you solve these the way that you're used to. Now, if you are asked to graph this, here's 7, there's negative 1. Because it's greater than or equal to, we fill it in, and it's greater than. Because this one's less than or equal to, we fill that one in as well. So if you're still not sure if it's supposed to be an and or, now you can look at the graph. The graph is rabbit ears, so that's going to be or.